Hello champions, I hope you all are well. Let's do some numericals based on work, energy, bar and collision, and there is one important concept from JEE Mains as well as medical point of view. Let's discuss that numericals today. Let us suppose there is a body which is dropped from a height h, and after collision it reaches to some height, let's say h1, and then again after one more collision it reaches to a height h2. All these motions will be vertically only. Now we know that the height is reducing, it means the collision is inelastic, and in an inelastic collision, let us suppose E is known to us, which is called as coefficient of restitution, and if capital H is known to us from where the body is dropped initially, and if E is known to us and we would like to identify the height to which the body will rise after nth collision, or we would like to identify what will be the total time of journey after infinite number of collision, or if we would like to know what will be the total distance covered during the whole journey, means capital H, then h1 up, h1 down, h2 up, h2 down, and so on. So let's focus on this numerical and let's try to identify this. From the definition of coefficient of restitution, we know that it is defined as the ratio of velocity of separation to the velocity of approach. Now here let us suppose before hitting, the velocity is u, and after collision the velocity becomes v1, which is responsible for taking it to a height h1. So we can write it as v1 minus 0, because earth before as well as after collision will remain at rest, and here before collision let us suppose the speed is u minus 0. Now you know that v1 can be written as root of 2g h1, because the speed will take the body to height h1, and u will be root of 2gh using the same concept. Now once you square on both the sides, then E square will be equal to h1 by capital H. So height after first collision will be E square of capital H. Now height h2 will be E square of, before that height was h1. Now h1 can be replaced, so it will be E square h, so e to the power 4h. Similarly, after nth collision, height to which the body will rise can be written as e to the power 2n times the initial height. So this formula can easily be used to identify height to which the body will rise after nth collision. Now you can easily calculate the time of journey as well. How to calculate the time of journey? You know that once the body was dropped from height capital H, time is, let's say, t. Now this h1 time from bottom to top, and then again top to bottom, will be twice of, let's say, one side t1, then twice of t2, and so on till infinity. You know that whenever a body is dropped from height capital H, time it will take to hit the ground will be root of twice of h upon g. Now this can be written as twice of 2h1 by g. This can be written as twice of this, like this. Now we know that if you will replace this h1 with e square h upon g, and this h2 as e to the power 4h upon g, and so on taking root of 2h by g common, it can be written as 1 plus twice of e plus twice of e square up to infinity. Now what we can do is, I can take 2e common from this factor, so it will be 1 plus e square up to infinity. And now using geometric progression, we know that the sum of infinite series is first term upon 1 minus common ratio. So it will be twice of root of twice 2h by g times, once you take LCM it will be 1 plus e upon 1 minus e times. So what you can do is just take the first time and just multiply it with 1 plus e and divide it with 1 minus e. You will get the total time of journey. In the similar manner, you can also calculate the total distance covered during the journey. So till infinity the distance will be capital H plus twice of h1 plus twice of h2 till infinity. Now in the similar way, h1 can be written as e square times h, h2 can be written as e to the power 4h and up to infinity. H common 1 plus 2e square plus 2e4 up to infinity. Now here you can take 2e square common, so it will be 1 plus e square plus e to the power 4 till infinity. Again using the concept of GP. First term is 1 upon 1 minus common ratio is e square. So it will be, after taking LCM, 1 plus e square upon 1 minus e square times the initial height from which the body was dropped. So from here you can easily see that the total distance covered, h1, h2, h3, h4, after infinite collision, the distance covered will be h times 1 plus e square upon 1 minus e square. Here the time of first body will be dropped from height h, time to reach the ground, and thus multiplied with 1 plus e upon 1 minus e, total time of journey, and the height to which the body will rise after nth collision will be given by e to the power 2n times the initial height from which the body was dropped. So in this way, just practice numericals, and soon we'll come with one more video. Thank you.